This lesson is about trig transformations, horizontal. We're going to split the horizontal into two different parts because it is a bit trickier. Let's jump down to the interactive panel. Same kind of panel as last lesson. So let's add in 5 points here, and you can follow along as I'm going. Feel free to pause the video and fill it in yourself. And I'll prompt you to pause at specific parts, but you can pause and follow along at any point you want to. So we have our original sine of x. Let's fill in those points. So go ahead and pause and fill in the original points for a sine function. Remember, for the x coordinates, we're going to do 0 and then evenly space it from here to 2 pi. So the last one will be, so the first one's 0, last one's 2 pi, and then what goes in between? It's going to be the halfway point there, and then pi, and then the halfway point there, and then that's it. Pause the video, try that, fill in the x's and then fill in the y's. I'm going to do it now. So this one will be pi on 2, because it's halfway to pi, which is there. And then, I should explain as well, you can press tab if you're a speed freak like me, and you want to do it faster rather than like reaching for the mouse. You can press tab and it moves between each one. Okay, 3 pi on 2. And then the y values is going to be 0 there, and then it goes up to 1, and then down to 0, and then down to -1, and then back to 0. Let's press save, move all those points out, and then we can graph it with the frog. Make sure we got all the points. Very nice. Now, let's do our first horizontal translation, and that would be 2 minus something. Now the x is in radians, so if we're going to plus and minus, let's make it compatible with that. So let's use radians ourselves. Let's just do minus pi on 4. Let's do that. Now this is the interesting part. Last time we were just changing the y values. Here, and maybe it makes sense as well because we're just literally going to the x value and minusing or plussing something from it. This time the y is going to stay the same, and we're going to change the x values. So, think about, to get an output of y, we have to input 0. But, let me draw this out, I think it'll make more sense. That was from last lesson. So, instead of thinking about just x as our input, because that's the thing that goes into the sine function normally. So x is sort of the input to the graph, but if we're thinking about inputs into the sine function, it's really just whatever is in here, whatever's in the sine brackets is our input, because then the sine will do its thing, and then you'll get an output, and if there's nothing on the outside, you'll get that output that goes between -1 and 1. So what I mean is, if we think back to the intro lesson we did, if we're looking, I'll unlock all these panels here. So if we do some stuff here, so we're going to minus pi on 4, I believe. So just pi on 4 because it's already minusing normally. And then we press play. See how like things get messed with the angle, like these angles are different now, but the output is still between 1 and -1. So x is sort of an input, but the input we're going to talk about here is more like an input into the sine function. So the input of the sine function is the x, but also anything else we do. So if we minus pi on 4, or pi on whatever, or whatever we do, or if we times that by 3, try and squeeze a 3 in there, that is all the input. So we sort of have an input of x, but we also have this other way we can think about the input, which is the input into the sine function. And that's what we're probably going to more focus on. So going back to our graph here, to get an output of 0, we need the input to sine to be 0. So what I mean is, let's scroll down a bit. Actually, I'll keep that there. So to get, if we have y equals sine of something, just put a blank box there. To get an output of 0, we need to have sine of 0, okay? Obviously there's other, we could also have as like sine pi, but if we're just talking about that first, that first point, we can think about that comes from sine of 0. So whatever's in this box here needs to equal 0. So if we have 0 equals sine, and we have x minus pi on 4, and we need this bit to be 0, then we can't just have x being 0, because then that's 0 minus pi on 4 equals negative pi on 4, which won't, well, it may or may not, but it's not like the 0, it's not going to give us the 0 we're looking for, right? And yeah, this one definitely won't equal 0. But if we were minusing like pi on 2, for example, then that one might work. No, it has to be like pi. Anyways, point is, this is not what we want. So instead of x being 0, we need to make x something else. So what minus pi on 4 would give us the 0 that we're looking for? Well, it would just be pi on 4. Because pi on 4 minus pi on 4 is 0. Let's change that one. So get rid of that, and let's make this pi on 4. So now if we were to put in pi on 4 for x, pi on 4 minus pi on 4 is 0, and sine of 0 is 0. So that's great. What about this next one? So to get this point, we would want to have sine of pi on 2 to get our 1. Let's write that down. So sine of pi on 2 gives us our 1. But we have sine of x minus pi on 4, and this, we want this to be pi on 2. So we can't just make x pi on 2, because then it will minus pi on 4, which I think will just be pi on 4, so that won't get us what we want. So we need to think about what, and that's x, so what does x need to be? So what minus pi on 4 would give us pi on 2? And you actually can just use algebra for this, so you could write it as x minus pi on 4 equals pi on 2, and then what's happening to x? It's minusing, it's getting minused by pi on 4, so we can add pi on 4 to both sides, which will cancel there, and we just get left with x equals whatever this equals. And then to figure this out, we'd want to make the bottom 4 by timesing the top and bottom by 2. And so now we have 2 pi on 4 plus pi on 4 gives us 3 pi on 4. So now we know if we want to get this output of 1, we need to go sine of 3 pi on 4, and then we'll have our minus pi on 4, and this will equal pi on 2, and that will get us our 1. If this is not super duper making sense, but it's making a little bit of sense, that's a good place to be in at this point, okay? I'm going to give you lots and lots of practice at it. So let's change this to 3 pi on 4. That's what we said, wasn't it? Yeah, 3 pi on 4. Cool. That gets us our 1. Now, next one. We want to have it so that sine of pi will give us our 0, but we can't just make x pi because then it'll change. So going over to here, we want 0 from sine of pi. And so we want to know what x needs to be, so that when we minus pi on 4, we will get this whole thing to equal pi. And so we can write it down. We can go what minus pi on 4 equals pi, and then we can add pi on 4 to both sides to cancel out that, and that will just tell us what our blank is. Let's change this so it's over 4, so we can add the fractions. Quick refresher on fractions if you need it. We can't add or subtract fractions unless they have the same denominator. Currently, technically the denominator of this one, we could write it as 1. So we need to make it into a 4 somehow. And so this one's easy, we can just times top and bottom by 4. And so we have 4 pi on 4 plus pi on 4, and we get 5 pi on 4. And so if this thing in here is 5 pi on 4, if I can squish that in there, then 5 pi on 4 minus pi on 4 will give us 4 pi on 4, which is just pi, which is what we wanted. So this guy needs to be 5 pi on 4, and that will get us our 0. Okay, next one. Maybe pause the video and see if you can do it yourself. So I would write down something like, we want -1, So -1 equals, and we got that from sine of 3 pi on 2. Sine of 3, oh, what am I doing? Pi on 2. And then we actually have sine of x, or you could put a blank box because we want to know what it needs to be, minus pi on 4. And that thing needs to be 3 pi on 2. So pause the video, see if you can figure it out yourself. I'm going to do it now. So 3 pi on 2. And we're starting to see the pattern here. You can write it out fully and use the algebra. But really, see how we just end up plussing pi on 4? And we did that previously here, plussing pi on 4, because that will cancel out the minus pi on 4 that goes on the left-hand side. So really we just need to get this value and plus pi on 4. And then we need to make this 4, so we'll need to times the top and bottom by 2. And then 3 times 2 will give us 6. So it's 6 pi on 4 plus pi on 4, so it's 7 pi on 4. And then 7 pi on 4 minus our pi on 4 will give us 6 pi on 4, which will simplify to 3 pi on 2. Okay, I went through that a little bit fast, but hopefully it makes sense. And if not, don't worry, we're going to get lots of practice. Okay, there's our 7 pi on 4 to give us -1. And then last one, to get this 0, like obviously there's lots of different ways we can get 0, but to get this particular one, we wanted to have an input of 2 pi. So we wanted 0 by doing sine of 2 pi. And so pause the video here, think about sine of what minus pi on 4 would give us our 2 pi. What we have to change, and think about what we've been doing each previous time to change it, to deal with this offset here. I'm going to do it now. So again, we've just been adding pi on 4 each time, which kind of makes sense. Like if the only change was minusing pi on 4, and we want to still have what we originally had, we can just get what we originally had, which was, originally we had 2 pi, and then to get rid of the minusing pi on 4, we can add pi on 4. Okay, and that will kind of counteract everything. And so this and this, and so what's 2 pi on 4? No, not that. What's 2 pi plus pi on 4? And that way we can offset that little guy. Yeah, so 2 pi, we need to make this into being over 4. So currently it's over 1, so if we times it by 4 on the top and bottom, we'll get 8 over 4. So 8 pi on 4 plus pi on 4, and we get 9 pi on 4. Let's put that in here, 9 pi on 4, and that will get us our 0. Now, moment of truth. How did we go? Let's press the save button here. And then, oh, okay, we can see everything kind of shifted. And then one of our points went off the screen. So let's change this. I think you can use complicated fractions and stuff, but I just want to make this 3 pi, just so we can use a simple number. Let's press play now, because we've already saved it. So press play to move everything. Interesting. So this should be our, Okay, well let's press the frog button and see how we went. Okay, so far so good. Cool. Oh, and then he stops. Okay, so we're going to need to make sure the frog goes, so the frog settings here, let's change this to go to, we'll make him go to 3 pi. So go ahead and change that, and then close this and press the frog again. Let's watch him. Now we should go all the way. Nice. Okay, cool. So we hit all the right points. But let's press the left and right here. So this was our original, so which means this here is 2 pi. It might look a bit weird because now we have 3 pi on 2 in the middle and 3 pi there. But yeah, this was our original. And then as we applied our transformation, what happened? Like, how would we describe this movement? I would say it's just moving left and right, like it's shifting left and right, as opposed to stretching. There's no stretch because everything stays the same distance apart, but everything just moves. It's like dragging something across the table. Interesting. Let's compare that to what we're doing in this lesson here, I'm going to close off the output because nothing's being affected there. When we had our pi on 4, what was actually happening? We had our angle, and then it was just getting shifted backwards to there. And then here, it gets shifted backwards to there. Here, it's getting shifted backwards to there. So it's always just getting shifted. Now, here's what I find interesting. What is our angle getting moved forward or backwards here? I would say the angle is here and it gets moved backwards to only there. And so backwards makes me think it moves to the left. So why on our graph do we move to the right when we're minusing and we're like shifting the angle backwards? Isn't that interesting? There's two ways to think about this. You can think of it like a delay. And so if I'm delaying someone, let's imagine that this is actually time here. And someone's going to arrive with 0 delay, which means they arrive right there, which would be this guy. But now imagine that I delay him. He's actually going to arrive, let's say he arrives like 5 minutes later or 10 minutes later or something like that. Now, do you think that it should move to the right? Like that seems more intuitive to me, that if I delay someone, they're actually going to arrive later, which would be like, if this is midday, then this would be like 12:10, which would be later. So now the kind of the delay that actually moves to the right, that actually kind of makes sense now. And especially when we think about minusing, we're thinking, oh, minusing, that means we move to the left, right? I mean, left, correct? And that seems like intuitive in your head, but then when you think of it in terms of a delay, it makes a little bit more sense. And also think about how what we actually did, the transformation is minusing pi on 4, but what we had to do to each of these guys to offset that was actually plussing. If we look back to our working here, all of the working was just plussing pi on 4, plussing pi on 4, plussing pi on 4. So even though we wrote the transformation of minus pi on 4, it's interesting because minusing pi on 4, the actual thing we do with that is to plus pi on 4. So now it does make sense that we move to the right, which is plussing. So it takes a little bit to get your head around. Eventually you can just memorize it as, transformations that are done on X are actually kind of the opposite. And so you kind of flip them and you kind of just get used to that. But if you can understand it more deeply and think about, okay, like I'm delaying it, which means I'm going to move to the right. Or you can think about how minusing actually means that to get the same point for the Y, we need to plus. Then it makes a lot more sense. Okay. I think that's everything I wanted to talk about with that part there. So now I want you to try your own. I want you to do, let's try like pi on 3. Okay, let's clear this current history to reset our points to there. And then, you can don't worry about the graphing the frog. We're just going to have this yellow line in the way. I want you to think about what you'd have to do to make all these points work. So remember, we're not going to change the Y values here. We're only changing the X. Okay, so do similar working to what we're doing. Think about all this stuff. You can flick back in the video to check what we did and remember, or just look at your own working. And yeah, give it a go. So pause the video. Now I'm going to try it. Now here's the speed way. Once you get used to it. If we want this X part to be 0, but whatever we put in for X is going to be minusing by pi on 3, we just need to add pi on 3. So if I put pi on 3 here, pi on 3 minus pi on 3 is 0. So then we'll end up putting 0 there. And then for this pi on 2, if I put in a pi on 2, it's going to get minus by pi on 3. So to offset that, I have to plus pi on 3. Now, what do I actually get by doing that? Okay, the numbers are kind of tricky here, so I am going to write down the working for this just to show you the first time. So we want a pi on 2, but to offset, we have to plus pi on 3. We can't just add these because the denominators are different. And we can't just times 1 to get to the other, like we did in the previous one, because they're not super compatible. So we have to cross multiply. because if I times this by 3 and this by 2, we'll end up with 2 times 3 and 3 times 2, and these are both 6. Okay? So a bit of cross-multiplying revision for you. I'll actually do it now. So if I get the pi on 2 and times the top and bottom by 3, and then I get my pi on 3 and I times the top and bottom by 2, this is actually all I really care about, because 2 times 3 gives us 6, 3 times 2 gives us 6, and then the top pi times 3 is 3 pi, and then we have 2, well, pi times 2 is 2 pi, and then now we have the same denominator on the bottom. And then 3 pi plus 2 pi is 5 pi. And then the 6 will stay on the bottom. Okay, so we actually need to put in 5 pi on 6 here. 5 pi on 6. And that will get us our 1. And I'll show you that properly, just because this one was a weird number. Sine of, and then this is going to be x minus pi on 3. But for x, we're going to say 5 pi on 6. And then minusing pi on 3. And what will we get? Well, we need to make sure this has the same denominator as this one. So if we times the top and bottom by 2, so 2, and times this by 2 to get 6. And now we can do 5 pi minus 2 pi gives us 3 pi on 6. And 3 pi on 6, the 3 and 6 can turn into 1 over 2. So really we just have pi on 2. And so by doing all that, we'll end up with sine of pi on 2, which is what we wanted to get our 1. Cool, so next part, we get our pi, we have to plus pi on 3 to that as well, to offset the minus pi on 3. And then to make this pi have the same denominator, we could go 3 pi on 3. And then 3 pi plus pi would be 4 pi. So the whole thing should be 4 pi on 3. So let me clear all that. 4 pi on 3. That should give us our 0 once everything's said and done. This one here, another weird one. So if we want to add pi on 3 here, oops, to offset things, we'd have to cross multiply again. So you can do the working for that, but I'll just do it real quick. We would times these guys by 2. No, we'd times these guys by 3. And then times those guys by 2. So this would end up being a 9. This would end up being a 2 pi. And then 9 plus 2 is 11. And the denominators would be 6. So we should be good to just do 11 pi on 6 there. Cool. And if you want to see that properly, just write it down like this. Do the cross multiplication. You should be fine. And then this last bit, we want a 2 pi. We have to offset the minus pi on 3. And then we want to make this be over 3. So we'll have to times the top by 3 as well, which will get 6. And so this one should be 7. 7 pi on 3. Cool. Again, feel free to write it down properly. Okay, I think this looks right. Let's try saving these points. Okay, they've shifted. Interesting. And then we should be right to just press play on the frog. Let's see. Oh, good. Nice. Nice. Good. Perfect. Okay. Great stuff. And so, yeah, let's compare that to the first one, like the original of sine of x. And what's happening? Everything's shifting to the right. Let's reset it. And watch it one more time. This is the original. Let's shift it to sine of x minus pi on 3. And everything shifts to the right. Let's look at it with this intro lesson that we did. Make this pi on 3 this time. And same thing. We have an angle that we put in for x, but then we're minusing pi on 3, and it just ends up there. So when I'm at pi, I'm actually up here, which is 2 pi on 3. Okay, so everything's just getting delayed. And so again, we might think, well, a delay, or like moving and minusing, that should be moving to the left, yeah? That should be going this way. But remember that Remember, you can think about it like a delay, which means it arrives later. So this point arrives, instead of this point arriving here, and this point arriving here, because we delay them, those points actually arrive later now, which would be there. You can also think about how, for all our working, we were trying to offset the minus pi on 3 to get the point we wanted. And so to offset that, we have to actually plus. And so plussing on the x-axis does make sense to go to the right. Okay, cool. Now, we haven't talked about timesing yet. So remember, we can also times the angle, which will make it move, basically makes it move faster. We're going to talk about that in this next lesson up here, which is number 2. For now, I want you to go and try these practice questions down here, because if we really get super confident with these individual parts one by one, even if maybe to some of you it seems like it's going a little bit slow, if you really master it, once we get onto the next parts, and especially when we start combining them all together, so we're going to have combinations of all the transformations. So we're going to have a value for B, a value for H, and then also a value for A and K. There are 4 things going on at once, and you get something complicated like this. And so by that point, it's going to be great that we've gone so slow and really mastered these points. Okay, so give the practice questions a go. Don't forget there's video explanations for each one. And then when you're finished, you can tick this lesson off and move on to the next one.